This course on Unreal Engine is meant for complete beginners. Our main focus will be on building an outdoor sculpture park, where we'll create a landscape with a Heightmap, make a landscape material, and import assets from Fab and other sources. We'll also use the Foliage painter to place trees, rocks, and flowers in the landscape. And of course, we'll add sound to the project too. But before that, we'll do a few short exercises to introduce some fundamentals of Unreal Engine. I think people learn best by doing, so each segment is organized so that you can easily follow along on your own computer. We'll start by building a simple room to provide an overview of how Unreal Engine's editor works and give you some practice using different types of assets. Then we'll show how mannequins can be added to the first-person template to use as a scale reference. We'll look at how to import meshes from Zbrush and give a quick explanation of Nanite. We'll build some materials from scratch and look at how UV mapping works. And finally, we'll show how you can make custom textures in Photoshop and how vertex color can be displayed on a mesh. My first experience with Unreal Engine was in 2018 when I used it to make a virtual reality experience about an artist-scientist from the 1800s named Ernst Haeckel. I also recently used the program to create a virtual art gallery, which was part of my exhibition last winter at Dickinson College. I've been teaching Unreal Engine in a university course on virtual reality for the past 4 years, and I'm excited to share this content to help accelerate your learning. So let's get started. To get started with Unreal Engine, the first thing you'll need to do is to download the Epic Games Launcher. So you can go to epicgames.com and then click on the download button in the top right corner to install that program. And then once it's on your machine, it will look something like this when you first open it. You'll need to go on the left-hand side to the Unreal Engine section and then click on the library button on the top. And this will bring up a panel at the top that has the engine versions that are installed on your machine. If you want to work with a version of the engine that's not listed, you can click on the plus button and that will bring up an option to install it. Now, down below here, we have all the projects listed that we've previously created, but we're going to create a new one here. So what we'll do at the top right is select from the drop-down the version of the engine we want, and then click on the launch button. And this opens a panel with our existing projects listed at the top, as well as some templates that we can choose from to start a new project. And in this case, we're going to work with the first person template. So I went to the games section, clicked on first person, and now on the right hand side, we'll set some of the options. So we'll work with the blueprint. The target platform is desktop. The quality preset is maximum, and we want to include starter content. So click on that box, and we'll call this FP_tutorial, and click the create button at the bottom right. If it's your first time launching Unreal Engine, it might take a while for all of the shaders to be prepared, but once they are ready, you'll see a screen that should look something like this. Now, all of the information for this project is saved in a folder that Unreal Engine just created. So within the Documents folder, there's a subfolder called Unreal Projects, and we called this project FP Tutorial. So all of the information for this whole project is saved here. If we double click, we could potentially launch the project from this button right here, FP Tutorial. The main reason of showing this to you is that now you know where the files live, so that if you ever want to back them up, you can just copy this entire folder over to an external drive. Now if we go back to Unreal Engine and look in the editor window, we can start to move around in the level. The way that we can orbit our view is by holding down the right mouse button and dragging. We can go forward with the W key, backward with S, to the left with A, to the right with D, and then we can go down with Q and up with E. And if we want to focus on something, we can select it and push the F key. And then if we come up to the top and click on this green button here to play the level in the active level editor viewport, that will show us what it's like when the game is launched. And so we have some slightly different options here. We can actually possess and shoot things. We can no longer go up and down with Q and E, but we also have now the option to jump with the spacebar. In this follow along exercise, we'll make a simple room with some of the starter content. Unreal Engine's editor interface may feel overwhelming initially, but most users primarily focus on a small subset of features. To help you get up and running quickly, this exercise will focus on just a few of the common features that are often used in the program. In this segment, you'll learn about some of the asset types available in Unreal Engine and get some hands-on practice using the assets in context. I expect there will probably be some questions about the specs on my computer, so I went ahead and pulled up this screen to show you briefly. To build our simple room, we'll pull in several assets from the content drawer. The content drawer contains all assets available in the project, including some already used in a level and others that are not yet included in the level but are just available for use. To access the content drawer, just click this button in the lower left corner. Let's go to the starter content folder, and then we'll open the architecture subfolder and drag the file named wall door 400 by 400 into the editor window. Again, to move our point of view in the editor window, we can do that by holding the right mouse button and then pushing W to go forward, S to go back, A to the left, D to the right, or Q to go down, and E to go up. And if we want to focus on something that is selected, we can push F. Now with something selected here in the center, if we hold the Alt key and left mouse drag, that will let us orbit around the selected item. If we let go of the right mouse button and push W, you'll see a little widget pop up that lets us move the item around in space, or E will let us rotate, Control Z to undo, or R will let us scale the item. And if we push Q, it'll put us back to the original kind of basic selection mode. In the top right corner, we have a number of settings that will affect the way that the widget behaves. So some of the settings have to do with how the widget will snap to surfaces, and then just snapping to increments as well. So we want to actually, just to make things simple for ourselves, let's set the rotation snapping to 90 degrees so that when we push E, we can just rotate this over like that. And let's pull it up a bit so that this can be the front, the entrance to the room. And actually, let's grab our player start thing and move it over here. And I'm going to rotate this as well to face toward the room. Now we'll add some more walls to the room and put a ceiling on it. So let's open up the content drawer. And as you saw before, as soon as we click away from the content drawer, it closes. I don't like it to do that. I prefer to keep it open. So let's go over to the right here and click on Dock in Layout. And we'll just click up there. And it becomes the content browser. I don't know why. But from here, we'll go ahead and drag in wall 400 by 400. And if we push W, that opens up the translation widget. And we'll just move this into place so that it overlaps that front wall a bit. And then if we hold the Alt key and drag on that handle, that lets us make a duplicate. And let's make another duplicate. So I'll hold Alt. Actually, let me push E and hold Alt, and I think that will let us rotate out a duplicate. Good. Okay, W to move, and that looks fine. And then we'll make ceiling for this by holding Alt and dragging up. Push E and rotate this down. W to move. And there we go. As you're working on positioning the walls and ceiling, if you find that your camera moves around too quickly, you can adjust the camera speed here. So I think by default it is set at 1, which is kind of quick. So I have it set at 0.33 right now. Now we'll add a light to the room, and we can do that by coming up top to the Quickly Add to the Project button. And we can navigate down to lights and grab the point light we need and drag it in. I prefer, though, if I'm going to be pulling in multiple assets from here, to just use the Place Actors panel, and this will dock that menu on the left-hand side. So I'm going to go up a bit like this, and then drag the point light in so it's on top of the roof like this. And then we're going to change from the perspective window to the top. And because the light is still selected, we can push F to focus in on it. And we'll just use our move widget to put this at the center of the room. And then if we go back to perspective, we can then orbit down inside of the room. Whoops, I forgot to lower it. Put this down a bit, and we'll just go inside the room to make sure that it looks like it's at a good height. With the point light selected, we have some options in the details panel in the lower right that we can change. And so the details panel shows all of the settings that pertain to this asset. And all I want to do here is just lower the brightness of the light. So right now it's set to 8 candelas. I'm going to set it down to 2, which I think is more reasonable for this space. Now let's do a quick overview of the content browser and some of the other asset types we'll use in Unreal Engine. These assets were all created with the first-person template. Let's go to the first-person folder and then open blueprints. Here we have blueprints for the first-person character, the projectile, and the gun. A blueprint in Unreal Engine is a tool that lets us create game actions and behaviors by connecting blocks instead of writing code. So for example, BP first-person character defines all of the logic for how the first-person character can move around and interact with the stuff in the level. Now let's open the Maps folder. This first-person map is where the information for the level you see in the editor window is stored. Now we'll go to the level prototyping folder and we'll open the meshes subfolder. These 5 meshes were used to make this level. In the lower left of each tile, you can see that these are static meshes, which means that they're pieces of 3D geometry. By the way, we can change how the assets show up by clicking the settings button and then switching to tiles, list, or columns at the top. And at the bottom, you can also change the thumbnail size. Anyhow, we can double click to open a static mesh. This shows us the static mesh editor. Like in the main editor window, here we can Alt-right mouse drag to orbit around the mesh. In the details panel on the right, we can see all of the settings that have been applied to the static mesh. This tile shows the particular material that has been applied to this mesh. Now let's go into the materials folder. A material is a type of blueprint that defines how the surface of a static mesh looks. There's a result node on the right that collects information from the nodes on the left. In this case, the base color is being set by a 3-vector node, the color of gray. Metallic is being set to 0, meaning not metallic. And roughness is being set to 1, meaning totally rough. Materials can get much more complex and often involve textures. Textures are JPEGs that are added to materials to be mapped onto static meshes. There are different types of textures. D means diffuse, having to do with the color of the material. M means metallic, affecting how shiny a part of the material will be. N means normal. Normal maps let us simulate 3D surface texture. Now we'll add some more elements to this room. You may remember when we first created our project, we clicked a button to enable starter content. By doing that, that gave us a whole collection of assets that we can use in our project. So let's go down to starter content and then props. And the first thing we'll drag in is a table. So if we scroll down to SM table round, we can bring that into the room. And it doesn't have to be perfect, but I want to get it a little bit more centered. And then we'll drag in SM statue and put it on top of the table. And then let's drag in a rock. Where is the rock? I think it's SM. Oh, it's just not showing up the preview. SM rock. We can drag that in and put it back in the corner. It looks a bit large. Let's scale it down by pushing R. And if we drag on the blue handle, it will let us scale the rock one-dimensionally. But if we want to scale it uniformly, we can grab that white handle in the center, and that will make it smaller without stretching it in one direction. Next, we'll add a door frame, but before we do, I just want to draw attention to the prefix that we have for this asset. SM, obviously in this case, means static mesh. It's common also in Unreal Engine to put M before a material, T before a texture, or to include BP as part of a name if it's a blueprint. And the reason that that's helpful is when you start to get to where you have hundreds or thousands of assets, it is very helpful to just have a way of quickly telling what type of asset something is by its name. Now we'll drag in the door frame. It's not quite big enough, it looks like. So we'll scale it out. I'll push R and then scale it one-dimensionally to make it a bit larger. And then we'll drag in a bush to put on either side of the entrance. And I'll push W so we can move it forward some. And to copy it, we'll Alt-drag. I feel like there's not quite enough light on the front of this room to be able to see the bush as well. Fortunately, we're in a simulated outdoor environment, and if we look up, there's even a sun above us. We can change the angle of the sun to better illuminate these bushes. We can do that by holding Control and L at the same time, and then we can drag our cursor around until we have an angle of the sun that we like. Now I want to do something a little bit absurd because we can, and add a fire inside of the room. So I'm going to go to Blueprints and drag in Blueprint Effect Fire and put it here. And I'll move it up just a little bit so it isn't submerged into the ground. Without going totally down the rabbit hole, let's take a quick look at the fire blueprint. If we open it up by double clicking and then go to the viewport, and in the top left click on fire, on the right you can see that we have some particles and some materials that are working together to make the blueprint, as well as an audio component. Now let's add a custom material to the left wall. So we'll change our point of view a bit, and let's go to materials, and for M basic floor, let's select that and push Control C, Control V. Where did it go? There it is. And double click to open that. And let's zoom in. I'm using a mouse without a click wheel. What is it? There it is. So for me, because I don't have a click wheel on my mouse, a middle mouse button, I have to Alt right mouse button drag to zoom in. Anyhow, all I want to do is just switch one thing about this. Let's change the base color to something a little bit more distinctive. I'll make it fuchsia color and press OK. And we'll save this and close it. And then we can drag this onto that left wall. Now let's go on a quick tangent and look at the starter map that's included with the starter content. If you open it up, you'll find a level that the good folks at Unreal Engine made to show some of the assets that are included in the starter content folder. This level displays several different materials, even including water materials that ripple, as well as blueprints, static meshes for the architectural elements, and some static meshes that are set up to simulate physics. So just push play and you'll see the floating golden forms fall down onto the roof. And when you're finished in this level, you can get back to your first person map by just going to the first person folder and then to the maps subfolder and then double click on first person map. We would be remiss if we didn't take a quick look at the outliner. The outliner is a way of just keeping track of all of the assets that are at work in the project. And so the bush, the first bush that we added is here, the second one is here, the door frame, etc. And we can organize these assets so that we can find them more easily going forward. So where it says first person map at the top, I'll right click, create a folder, and let's call this simple underscore room. And then we can drag all of these elements that we created into that folder. Now that we've finished adding all of the elements, I want to show you a couple ways that we can preview our project. If we just want to get a higher quality view of our project, we can push F11 to set the editor window to be full screen. And we can push G to turn this on game mode. And what game mode does is hide all of the icons. Now if we push F11 to close full screen and push the play button, That lets us preview the game in the editor window. What I don't like about the room right now is that when we come into the room, the table doesn't move. I want to set it up so that we can actually knock it over by running into it. So we'll push escape. Now in the editor window, we'll click on the table, and in the lower right corner, we'll go into the details panel and go down to the physics section. And where it says simulate physics, let's check this box. Now we'll select the statue on top of the table and again go down to the physics section and click on simulate physics. And then we'll push play. And now we can run into the table and knock it over. We can even get the gun, because this is set up to work with physics. We can use that to blast these things around. Giving realistic scale and proportions to static meshes is very important in Unreal Engine projects. When the elements are scaled accurately, the believability of a project is enhanced quite a bit. The easiest way to tell if the scale is right is to add a human body to use as a point of reference. And there are Mannequin forms that are built into Unreal Engine's third-person project that we can add. Let's go over the steps together. We'll open the Epic Games Launcher, start Unreal Engine, go into the Games area, and then start a new third-person project, including starter content. Then after your project is loaded, go into your content drawer and go to the Characters section, then to Mannequins, and then Meshes. And what you want to do here is click on SKM Manny Simple, and then hold Control and click on SKM Quin Simple, and then right-click and go to Asset Actions and Migrate. The program will then bring up a screen showing what's about to be exported. Just click OK. And then we want to select the project that we're migrating to. So we'll go to Unreal Projects and First Person Tutorial, then select the content folder, and the program will start to migrate the packages over. Then we'll go back into our first person project and open up the content browser, go to the Mannequin section, and then to the Meshes subfolder. And we want to drag in SKM Manny Simple and SKM Quin Simple. And there's one more trick I'll show you, which is that if we're making copies of these in our level, we can alt drag, as you know. But if we want to put this up higher, maybe to be on this platform, then we can push the end key on the keyboard to drop it to whatever surface is below. In this segment, we'll go over the process of importing meshes from Zbrush to Unreal Engine. But of course, before we can import, we need to have sculpted something in the first place. So if you haven't yet learned the basics of Zbrush, then I suggest checking out my grotesque Zbrush sculpting video. That will give you a good start. Here in this short video, I'll show you a couple of simple ways of exporting, then importing a model. This is meant as a quick first introduction, so we won't go over UV mapping in Zbrush, which means that if you apply a more complex material, you may need to make a few adjustments, but no worries. In the upcoming segment in this video on simple materials and UV mapping, I'll show you a quick and easy way of UV mapping in Unreal Engine that will work well for beginners. In our first, simplest example, we'll just download a mesh from the web, reduce its face count, and then import it to Unreal Engine as an OBJ. I'm on the website 3dscans.com, which has very high resolution scans available for free. We'll download this file, and then we'll extract the zipped file. Then we'll open ZBrush and start with the Dynamesh sphere template. Then we'll go to the right and import the file that we downloaded. And it comes in upside down, so we'll need to flip it over. I'll push W and then shift right mouse drag to make sure that I'm snapping to a rear view of the model. And I want to go ahead and turn symmetry off. You can see we've got two red dots there, meaning that it's trying to work across the axis. So having pushed X, that dot goes away. And now we can grab on this handle to rotate it around, and I'll hold Shift to constrain to 5-degree increments and push Q to turn off that widget. At the top of the screen, there's a display of the active points on this model, and it has 1 million points. We can technically get this to import into Unreal Engine and even get it to show up with decent performance in the program. But I prefer to optimize the geometry some in Zbrush before we export, because it will help to keep the file size of our Unreal Engine project more manageable. So let's push Shift F to polyframe so that we can better see the faces on the model. And let's go to the top to Z plugin, and we'll grab onto this little button at the top left, if it'll let me, and we'll bring this over and dock it on the right. And we want to go into Decimation Master, and we'll click this Pre-Process Current button. And at the top, we see an indication that the program is processing the model. And now that it's finished, we can go to the percent of decimation. So I'll set this to 10% to make it so that it will be 10% of its original complexity, and click Decimate Current. And the geometry has been simplified quite a bit. I'll push Shift F so that we can see how it looks. And you know, it really depends on exactly what you want to do with the model. If it's going to serve as a sort of a minor element in the background, maybe you don't need many faces at all. Or if it's going to be a hero element that is going to be seen large, full screen, maybe you need many more points than what we have here. But I think for this example, 100,000 points will work. So now we'll go to, under Tool, we'll click the Export button, and I'll save this on the desktop. And then we can go into Unreal Engine. And if you haven't yet created a folder for the assets that you're importing, I like to do that by right-clicking on Content and go to New Folder. And I usually call it 1_my stuff or something like that. The reason I put the 1 first is I want it to show up at the top. Now that I've navigated to my stuff folder, I'll click on this Import button. Then we'll import the file. I want to give us a little bit more room to see the model, so I'll move over here to this upper platform. And we'll just drop it here and rotate it into position. So this worked fine for importing the model. But what if we want part of the model to be a different material? So if we want the shield, for example, to be fuchsia. To do something like that, we would need to go back into Zbrush and break the model into 2 parts. So in Zbrush, what we'll need to do is make the shield a different polygroup and then break that off to another subtool. The way that you might first try to do this is by control dragging. I would recommend setting the focal shift to -100. The problem that I'm seeing with this, since we have the model already reduced to a low face count, is it wants to go up onto the hand when I'm trying to mask the shield. So I probably would not do that. I think instead what might be easier is to Shift Control, click on the brush, and go to Select Lasso. And then I'm going to Shift Control Alt select the parts of the shield. Then just go through and hide all of the parts of the shield. Now that we've hidden the shield, we can go to Subtool, Split, Split Hidden. And then we'll export the body and the shield separately. Now back in Unreal Engine, I'll select those files and import them. I find it much easier to drag them in at the same time so that they'll line up correctly. Then we can go back to the starter materials and put gold on the body and fuchsia on the shield. If you need to move these parts around, it can be helpful to group them together. So I'll click on the body and then shift click on the shield so that they're both selected, and push Control G. And now we see an indication here that they've been grouped together. And we also see this green bounding box pop up around. And so if we move it over, press escape, click on it again, they're still grouped. If we want to ungroup at any time, we can shift G to do that. In this segment, we'll introduce Nanite by looking at an example. We downloaded before a high-resolution mesh from 3D Scans. Let's bring in that full-resolution mesh. So we'll import it. And I'll check one setting here to just make sure that Nanite is being built on the import. Where is that? It's so under Static Meshes, go to the Build section and make sure that the Build Nanite box is checked. And I'll click Import. It's a pretty big file, so it took about a minute to import, but now we can drag this into the level. In the content browser, let's confirm that Nanite is turned on for this mesh. We'll right-click and go to Nanite and just make sure that this box is checked. Since Nanite is enabled for this mesh, we can go to the viewing mode where lit is currently listed, and then go down to Nanite visualization and change it to triangles. And now if we zoom in on the mesh, you can see that as we get closer, the program shows us more triangles, and as we go farther away, it shows fewer triangles. Nanite's automatic adjustment of mesh density is much easier than the old way of doing things in Unreal Engine by using levels of detail, which required multiple versions of the same mesh at varying poly counts. Something we're always concerned about when we develop a project in Unreal Engine is maintaining a high frame rate. So let's look at a specific example of how Nanite can help to improve frame rate. Let's go back to our content browser and we'll right-click and change this from Nanite to not using Nanite. I'll uncheck this box. Now that the model's Nanite triangles have disappeared, I think that it has successfully switched over. So let's go up to change back to lit viewing mode. And then let's take this model and move it down to the ground where we have a bit more space. Then I'll delete some of this starter geometry and make several copies of the mesh. What I'm trying to do here is create a situation where Unreal Engine will have a hard time maintaining a high frame rate. With 16 copies of the model, that gives us 16 million vertices. Now we'll click the play button at the top to play the level in the active level viewport. And you can already see that it's a bit laggy as we approach. And if we push the tilde key in the top left corner, so the key that is just below the escape key, and then type in stat space FPS and press enter, we then get an indication in the right corner of the viewport of the current frames per second. It looks like it's showing an average of about 12 to 15 frames per second, which is not nearly enough to provide a smooth experience for the viewer. So we'll go back into the content browser and right-click on the mesh, and then go back to Nanite and click this box. Even though we have already escaped out of the game, we still see the frames per second listed here. It looks like it's about an average of 65. Let's go back into the game and just confirm that it maintains that high frame rate as we approach. It does drop a bit, but still it's at 50 versus 15, which we had before. So that's a huge improvement using Nanite. Let's end with a few quick takeaways. One limitation to be aware of is that Nanite does not support transparent or translucent materials, including glass. Attempting to do so could potentially cause performance issues. And keep in mind that materials are not affected by Nanite's triangle reduction. Nanite will only optimize the 3D geometry. And as we covered in the last segment, even with the use of Nanite, I don't suggest importing meshes with millions of faces. That would increase the file size of the project too much, and imports would take a very long time. It's better to use Decimation Master in Zbrush to decrease the point count to something reasonable before importing to Unreal Engine. Let's talk about materials, how to create them, how to use material instances, and how to adjust UV mapping to change the way that a material shows up on a static mesh. Unreal Engine's starter content includes several materials. If we open the blueprints for these materials and look at how the nodes are set up, it can be pretty confusing for a beginner. So we'll start at the beginning and build a very simple material from scratch so that you'll better understand how they work. Let's create a simple material together. I'll go into my Stuff folder, right click, and then come up to Material, and I'll call this Very Simple Material, and then double click to open it. Notice when the material opens that we have a tab in the top left corner. If we grab onto that tab and pull down, we'll have the option to put this back behind our first person map. Instead of having several different windows floating out in space, I like to organize by tabs like this. Now we'll define the base color by holding down the 3 key on the keyboard and then left click in a blank space. And this gives us a 3 vector node, which has an input for X, Y, and Z, which basically just creates a color. So we can plug this into the base color. Right now it's set to black. We can change that though by double clicking here and set it to something else. I'll make it an orange color and press OK. We can also create a constant value for the roughness by holding down the 1 key on the keyboard and left clicking. And we'll plug this into the roughness node. Right now, because the roughness is set to 0, it means it's fully shiny. We can change this to 0.5, so 50% rough. And you can see here in the preview how the material changes. Now let's save the material by clicking this button in the top left corner. And then we'll go back out to the level and drop this onto a static mesh. Although that process worked, there are 2 big problems with it. As materials get more complex, saving them can start to take a while, sometimes even taking more than 15 seconds, which can really slow down your workflow. Also, we don't have a good way of reusing the material. For example, maybe we want to create a green version of the material for the next mesh over. Material instances help with both of these problems, so we'll cover those next. We'll locate our simple material in the content browser and right-click on it and then go up to the top to Create Material Instance. We can see that the name has just had a suffix added to it of INST, and in the bottom left corner of the tile here, it says Material Instance. So let's go ahead and open that up. We don't yet have much in here that can be customized because we have to make a couple changes to the material. Let's go back to our material and we will on the 3 vector node, let's right click and change this to a parameter. So convert to parameter, and we'll just call this base underscore color. And then we'll right click on the roughness node and change this to a parameter as well. Convert to parameter. We'll call this roughness and save. And then we can go back into the instance. And now we have a roughness variable that we can click on. Then if we put our mouse over where it says 0.5 and we drag to the left, we can modify that value to make it shinier, or we can drag to the right to make it rougher. And if we expand out this global vector parameter values area and click on base color, we can then modify this as well. So press OK and save the instance. And you'll notice that the saving happens almost instantly. Then we can come back out to the editor window and drag this instance onto another mesh. And we can even Control-C, Control-V on the instance and open up this one and change its color. So we can make this a purple. Press OK, save it, go back out, and then apply this to another mesh. Now that you understand these basics, let's make a material that uses textures that can enable us to get more sophisticated results. Again, in the My Stuff folder, I'll right click and go to Create a Material, and we'll call this Primary underscore Material. And open it up. And the first thing we'll need to do is define the base color with a texture node. So we'll hold down the T key on the keyboard and left click. And we'll plug the top output from RGB into base color. And then let's right click on texture sample and convert to parameter. And let's just call this base color. and it's giving you an error because we have not yet chosen a texture for it. So if we go over to the left side and define a texture here under Material Expression Texture Base, I'm going to use Hex, T-Tex, I'll use T-Tech Hex Tile M. And from here, we can create a little bit of space, and let's click, hold down the 1 key on the keyboard and left click, and we'll plug this into metallic. So let's right click, convert to parameter, and call this metallic. And let's see, we can Control C, Control V, and we'll paste this here and plug this into roughness. And then we need to change the name, so we can do that over here on the left, roughness. Currently, we have no way of controlling how big this texture map will be on the model, so we need to set up the tiling. So we'll drag a wire from UVs and type in multiply. And we just want the plain old multiply. We'll click on that. And then we'll drag a wire from A and type in TEX. And we want the texture coordinate node. And we're going to multiply this by an append node. So APPEND. And we want append vector. And it gives an error because we haven't yet plugged anything in. So we'll hold down the 1 key and left click and plug this into A. And let's right click on this, convert to parameter, and we'll call this U space tiling. And we want to set this to be 1 by default. So we can click there, set that to be 1, copy and paste this, and we'll plug this into B. And we just need to change the name of this one to V tiling. So we have U tiling and V tiling that are both set to 1 as default. The problem with the material we have so far is there's no simulation of three-dimensionality in the material. We really want there to be some bumpiness on the model that matches the hex tiling that we have so far. And we can do that easily by using the normal map that is already built in with the starter content. So let's hold the T key and left click, and then on the left hand side in the texture area here, I'll click where it says none, and let's type in hex, H-E-X, and we'll select the one that is blue. So this is a normal map, and we can plug this directly into the normal pin here on the right. If we left click and drag in this area, we can see that it does now simulate some three-dimensional deformation to the surface. The problem, though, with setting it up exactly like this is that we can't change this tiling, or it will be mismatched with the normal map. So we can fix that by just setting this back to 1. And then on the right-hand side, where we're feeding out from multiply, we'll plug that in to drive the UVs of the normal map too. So now anytime we change the tiling, it will affect both the base color and the normal map. And by the way, we want to right click here and convert this to a parameter as well. So we'll call this normal map. A final change I'd like us to make before we leave here is to set it up so that we can vary the intensity of the normal map. This is important because sometimes the normal map is too strong or not strong enough. So it's good to have the extra control. So let's actually alt click on this wire to delete it. And then we'll right click and type in LERP for linear interpolate. So that brings up this LERP node. And we can plug our RGB into, how do I want to do this? Let's go into B actually. I think it'll make a little bit more sense this way. And then we'll plug the output of the LERP node into normal over here, the normal pin. And then we want to hold down the T key and left click, and we'll plug this into A. And then we'll move these around to make their placement a little bit more logical. I had to pause the video there for a minute because I got confused about something. We want to plug in the base flatten normal texture here, but if you search for it, it won't come up. And that's because we are not yet showing the engine content. So what we need to do is go back out to our content browser And where settings are listed here on the right, click on that, and then click on the button to show engine content. This makes other folders available in the content browser. So we now have engine. There's a bunch of stuff in here you could look through. And it also exposes some textures in the material editor. And we will select here and type in base, flatten, normal, all one word. Base, flatten, normal. And then we want to finally create a variable for the intensity of the normal. So I'll hold down the 1 key and left click, and we'll right click, convert to parameter, and we'll call this normal intensity. And we want to plug this into alpha. And by default, let's set this at 1. Now we can go back to our editor window and find our My Stuff folder and find our primary material. Where did it go? Okay, and we'll right click on it and create a material instance. And let's go ahead and open this up. Now we have a bunch of variables that we can change on the right hand side. So let's enable all of these by checking the boxes. And we'll click on the base color and normal map to enable changing those as well. And let's see, I think it might actually be most interesting to go ahead and apply this to one of these statues out here. So back in the editor window, we can drop our material instance onto this sculpture and see how it looks. And right away, it's obvious that something weird is going on because the texture isn't showing up correctly on some of the more complex parts of the model, with the white lines breaking up. So what's going on here is that the imported mesh didn't come with UVs, so Unreal Engine automatically generated them with a UV mapping feature that's new in Unreal Engine 5 called Streaming Virtual Texturing, if you want to read up on it. But these auto-generated UVs are not ideal for more complex parts of the model. We'll come back to adjust the UVs in a minute, but for now, let's move over here and just create a few spheres. I'll go into the Place Actors panel, which remember you can access by clicking up top on the box with the green plus button, and then going down to the Place Actors panel to dock this panel on the left. And then in the Place Actors panel, go to the Shapes section, then drag in a sphere and adjust its scale and height, and duplicate it a couple times by selecting it, pushing W, and then Alt dragging on the widget a couple times. Now we'll drag the primary material instance onto the first mesh on the left, and you can see that the UV mapping is much better here. And then let's, in the content browser, select the material instance and do Control-C, Control-V to make a copy. And we'll go down and grab this second one and put it on the second mesh. And then let's open this up. And let's actually undock it from the top so that we can see the model as we change it. Make this a bit bigger so we can see what's going on. And so by sliding the UV tiling, you can change how big or small the texture maps are. We can also change out the texture maps by going into Global Texture, then click on the drop down, and let's use oak for this first one. So we'll just type in oak, and then we want T Wood Oak D for the diffuse map to define the base color. And then we'll click on the drop down for the normal map, and again search for oak. And here we want the one that ends with the letter N. Now the preview might not update right away. If it still shows the hexagons after you make the change, just orbit around in here to update it. And I like to actually zoom in on the mesh that it's applied to see how adjusting these settings will affect the texture. So for example, dropping the roughness down, you can see that the shininess comes down. Or if we adjust the tiling to make it bigger or smaller, that will update out here as well. Now let's go ahead and adjust the third one. So we'll close this out. Let's save it first. And then we'll just copy and paste this material instance in the content browser, Control-C, Control-V, and we'll drag this new one onto this. And then we can open this up by double clicking. And here, I think that there's also a material, or a texture rather, called Moss. Yeah, so T ground Moss D. We'll get that for the diffuse map for the base color. And again, we'll search for Moss to get the normal map. Now here it makes no sense to have it be shiny. Moss would always be very rough. And let's turn up, oh, I need to turn down my camera speed some. Let's turn up the strength of the normal to see if we can kind of exaggerate the surface deformation. And then we can play with the tiling as well. Now let's fix the UVs for the imported sculpture. We'll move back over to the sculpture and then click up top where it currently shows selection mode, and we'll change that to modeling mode. And then we'll click on UVs in the leftmost column and select project UVs. If your model has a lot of vertices, it might take a few seconds to process, but then you'll be able to set the projection type. For most 3D forms, box will work well, but if your form is more cylindrical, you may want to choose cylinder, and there's an option for planar mapping too. Now we can adjust the angle of the box mapping, so just rotate the widget until you're happy with it. And once you're finished, you can click this blue accept button in the editor window, and then the change will be applied. And of course, now we can open the material instance again and adjust it too. To wrap up, materials will get even more exciting once you learn to use panner nodes to drive the movement of textures, as well as opacity maps and emissive materials that are controlled by time and sign nodes. We have just scratched the surface of what can be done with materials in Unreal Engine, but this gives a decent start. In many Unreal Engine projects, you'll need specific textures that aren't included in Unreal's starter content. So in this segment, I'll very quickly go over the main considerations for searching for textures and how to make your own textures in Photoshop. When I need a certain texture, I first go to the web and see if I can just download what I need. It's much faster to just use an existing texture rather than create one from scratch. So let's look at an example. I'll search for brick wall texture seamless. Looking at the available images, there are a few things to keep in mind. First, make sure the image is square, like with the 512 by 512 pixel resolution, or 1024 by 1024, etc. Second, make sure the resolution is high enough for your use case. And third, you'll want to watch out for seams. When textures are used in Unreal Engine materials, they will repeat, so if the edges aren't set up to be seamless, they'll look awful. To get rid of seams, you can follow this basic process. Either download an image from the web, or shoot your own photo if the texture you need is from something you have access to, like concrete. If shooting your own photos, make sure to work in diffused light. So if you're working outside, it's best to wait for an overcast day or shoot in the shade out of direct sunlight. Once you've gathered your images, open them up in Photoshop, then crop to a 1:1 ratio to make them square. If your resolution is low, you can increase the image size some. Be sure to use these settings so that Photoshop will use an AI method to add detail during the resize. Now we'll take the first step to get rid of the seams. We'll go to Filter, Other, Offset, and adjust the sliders so that the seams are moved to the center of the image. After offsetting, we'll use the clone stamp tool. I usually just push the S key on the keyboard to access the clone stamp. Use the square bracket keys on the keyboard to make your brush bigger or smaller. Alt left click to define the source, then left click drag to apply the clone stamp. Now just randomly select different parts of the image and cover up the seam. Try to make it look natural, and make sure that you're using a brush with a soft fall off so that things will blend together nicely. Do the offset again just to check your work, and when you're finished, save the image out as a JPEG. Put an _D at the end of the file name so that you'll know later that it's a diffuse texture map that's meant for base color. Now you'll want to make a normal map too. Just search on Google for web-based normal map generator. Then feed in your image and you'll get a bluish version of your seamless texture. And when you save this file, make sure that the file name starts the same as the diffuse map, but add an _N to the end to indicate that it's a normal map. Now import your texture maps to Unreal Engine, apply them to your material, and you're done. You can also use ChatGPT to make some more unusual textures. Here are some textures I made of lava. But the textures from ChatGPT will probably need some work on the seams because in my experience, it tends to warp the images toward the outer edges. Some images may be difficult or impossible to make seamless. You want the lighting to be an even brightness left to right and top to bottom, not like this. And keep in mind that some repeated patterns could be very hard to get to match up right with the clone stamp. Good luck! In the last two segments, we've been using textures to define the base color of static meshes. Another solution is to paint colors onto a mesh's vertices in Zbrush. We can get those colors to show up on the mesh in Unreal Engine. For this example, we'll open Zbrush, we'll select a Dynamesh sphere to start with, and then we'll import our model. I'll just orient this so that it's upright. Now the resolution of our vertex color painting will be affected by how many vertices there are in the mesh. If I push Shift F, you can see that this is a super detailed mesh. We don't need this many verts though. I'll go ahead and knock this down to about 100,000 with Decimation Master. And then what we'll do is go up and adjust some of these settings up top. So we want to make sure that RGB is turned on. We want to make sure that Z add is turned off. And from here, we can go over to the right and make sure that polypaint is enabled. So click that brush if it's not currently bolded. And then you can see that we've got two dots on the model showing that we have symmetry turned on right now. I'll push X to turn that off. Now we'll paint some color on the model. And I'll just choose a few different options just so that there's some variation to it. Now that we've added some color to the model, we want to export. So if you don't yet have your Z plugin docked over on the right, the way that you can do that is by going to Z plugin and then grab that top left button, bring it over here to dock it. And then we want to go to FBX, export, import. And we want to export selected, binary, and smooth normals. We'll click on this button, and I'll just overwrite horsehead on the desktop. Actually, let's make it horsehead 2. And once that's exported, we can go into Unreal Engine, and we'll import our file. There's one key thing that we need to check during the import dialog. We'll just search for Vertex, and we'll look for Vertex Color Import option and make sure that this is set to Replace, and click Import. Now we'll drag the mesh into the level, and let's just get this to be up on the platform. We'll make it a bit smaller. Now we need to make a new custom material, so we'll come down to a blank space in the My Stuff folder, right click, create a material, and we'll call this Vertex Material, and open that up. And what we need to do here is just right click and search for Vertex. We want Vertex Color, so we'll plug that Vertex Color node into base color like that. So we're going from the top pin of the Vertex Color node into base color. Save this, and then we'll apply the Vertex material to our mesh. Here I've done a quick and dirty demo of how the process works, so the paint job on the horse is nothing to write home about. But the great thing about painting mesh vertices is it provides precise control over coloration when you need the colors to align exactly with the mesh's topology. When making a landscape in Unreal Engine, I find it easiest and fastest to use a Heightmap to do some broad, rough shaping. Then I go back over the landscape afterward with sculpting brushes to refine it as needed. The first thing we need to do is import a PNG file of a Heightmap. Here are a few that I created with Midjourney that you can use in your project. Just follow the link in the description to access these files. Or you can simply go to the web and type in landscape Heightmap PNG and choose a black and white top view image like this. Again, we want a PNG file, and we need to make sure also that it's a 1:1 square ratio. In the top left corner where it shows that we're in selection mode, we'll click on that and set it to landscape mode. And then where it says Heightmap file in this left column, we'll click on the 3 dots here to choose the file that we want to import. So I'll work with 2_Heightmap. And then we have a preview. I'm going to change my camera speed to be higher so that I can get around a bit more quickly. We have a preview of what the landscape is going to look like. It looks way too tall, so let's adjust some of the settings here. I think it's this last one if we want to make it, yeah. Let's make it a bit less steep, maybe like 25 instead of 100. And we'll click import. I plan to put the sculpture park toward the center of the map, and I want to keep the starter content in case we need to refer back to it in a future part of the tutorial. So I think what I'm going to do at this point is switch out of landscape mode into selection, and then now we can click on the landscape. We want to grab the whole thing though, not just a single square. So let's collapse this in the world outliner and then select that top level landscape, and then we can move this around. So I'll scoot this over so that the starter content is back toward the corner, back behind the mountain where it won't be seen. About like that. That should be fine. One of the worst things we could do when designing a new level in Unreal Engine would be to thoughtlessly plop a bunch of assets down on the landscape and start detailing. Doing this would likely give a disjointed layout, wonky proportions, and spacing that doesn't work well. Instead, we want to start with the level blockout process. This involves roughing out the level, sometimes using placeholder objects to decide how the elements will fit together. While the level blockout process takes a bit of time up front, it ultimately speeds up the project by providing a clear plan and allowing us to work more effectively as we add details. I began the blockout process by deciding where I wanted the player to start. I chose to put them here looking up toward the mountains. In this simple blockout example, I've included 3 primitive forms to represent the sculptures that I'll add later. I put the first one here near the player's start with the other ones down the hill. By each sculpture I put a mannequin to make it easier to understand the scale. Remember that you can push the End key on the keyboard to drop the mannequin to the landscape surface. To create the lake, I switched back to landscape mode, and in the sculpt panel I used the sculpt, smooth, and noise brushes to dig out the area for the water, trying to make it look organic and natural. The main brush setting I changed was the size, but you may also want to play with the tool strength too. If you left mouse button drag with the sculpt brush, you'll add to the landscape. Or if you hold shift and left mouse button drag, you'll subtract and lower the surface of the landscape. Then to make the water plane, I opened the Place Actors panel, went to the Shapes section, and dragged in a plane. I found that the scale for the water material was way too big, so I duplicated the water material so as to not mess up the original, and I adjusted the large scale tiling, the micro normal tiling, and the macro normal tiling. I actually increased all of these values to be 30 times bigger than they were initially. If you really want better control over the water tiling, you can parameterize the tiling like we did with our primary material. It wouldn't be too hard to do. You would just need to add multiply and append nodes and tiling parameter nodes that could be adjusted in a material instance with the sliders. I dragged the player start over from the starter content area, and I found that the game preview wouldn't launch. The problem was that I had put the player start at a location that was below -1000 in Z, and Unreal Engine doesn't allow a character to exist at this height by default. It's easy enough to fix this though. You can just go to Window, World Settings, and then search for Kill in the Details panel and set Kill Z to a greater value. So let's preview the game. I want the viewer to come up the hill and look at this sculpture, and then follow a dirt path leading down the hill to the next sculpture. Behind this second sculpture, I want to add a bank of trees to hide the third one, and then we'll follow a dirt path along the water's edge, and once we pass the bank of trees, we'll encounter this third largest sculpture. Even with this pretty simple blockout, I was surprised at how many adjustments I had to make to get an arrangement that I was happy with. But now we have a good plan, and I'm excited to develop the project further with you in the next steps. In the last segment, I mentioned that it would be possible to parameterize the tiling of the water material. I decided to make a quick video segment to show how that can work. Make a duplicate of the original water material provided in the starter content, then open the duplicate. Open your primary material and copy these nodes and paste the nodes into the water material on the far left side. Delete the U tiling parameter node, then rename the V tiling node to water tiling. Plug the water tiling node into both of the append pins. Then select all of these nodes and press the C key on the keyboard to add a comment and name it water primary tiling parameter. Now go to the micro normal section and scoot the texture coordinate nodes over to the left. Then create 4 multiply nodes. You can make these by holding the M key on your keyboard and left-clicking in a blank space. For each multiply node, plug the corresponding texture coordinate node into the top pin, then drag a wire from the water primary tiling parameter and plug it into the bottom pin for the multiply nodes. What we're doing here is preserving the original tiling values and multiplying by our primary parameter. We'll repeat this process for the large-scale tiling and the macro normal section. But in the large-scale tiling section, you will need to make this special adjustment where you take the scalar value, 0.05, and add it for both the U tiling value and the V tiling value in the texture coordinates. Once you're finished, the water material should look like this. Now save the material. Then all we need to do is create an instance of the material and apply the instance to the water plane. Then open the instance and adjust the slider. I found that setting the parameter to 100 worked decently well. It's still not perfect, but it's much better than it was, and this fix is really fast to implement. If you know of a better fix, please share it in the video's comments section. Let's look at some methods for adding ready-made assets to your Unreal Engine projects. Using these assets can help to speed up your workflow so that you won't have to do as much work building all of your own assets from scratch. Unreal Engine used to have a marketplace, which is no more. Unreal Engine also used to emphasize Quixel, but I've heard that it's going away. I've read that eventually all downloadable assets will be on Fab, but for the time being, there are also downloadable assets on Quixel too. So let's look briefly at how you can get assets from both Fab and Quixel. We'll open Fab by coming up top to Window, and then come down to click on the Fab button here. And then we'll come back up to Window and click on Quixel Bridge to open that. And once this loads up, we'll need to log on to our account. Now I'll dock the Quixel Bridge tab by dragging it down here. Now we'll go to the Fab tab and search for some free 3D assets. So we can constrain our search to the 3D models by clicking on that button at the top. And then on the right-hand side, click on Price and set this to free. And then you can scan down through the different assets that are available. But I did some searching in advance, and I know that I want to work with banana trees. So in the search bar, I'll type in banana plant. And the asset I'm looking for is called Tropical Vegetation Banana Plants. And we can then click on the Add to Project button to download. But there's a problem. This asset isn't compatible with Unreal Engine 5.5. In this case, I think it should be okay by just selecting version 5.4, but just know that we're cheating here. So there could be potentially some glitchy visuals or some performance issues. Now that the download is finished, we have a folder in the content browser called PN Banana. This asset pack includes blueprints, a map, Materials, Textures, and Meshes. Let's open the Meshes folder and drag some of these assets into our level. One of the challenges with ready-made assets is they can be unusual asset types or be configured in a way that you aren't familiar with yet. So making adjustments to these assets can sometimes be puzzling. These banana trees are meshes, but they move because they're animated using a vertex shader with wind settings in the material. I've read that vertex shaders are generally efficient, but in practice I've had some issues in the past with Unreal getting sluggish after adding a bunch of trees. So if something like this happens in your project and your frame rate drops way down, there are two steps you can take. A quick solution is to go into the editor window and click on this menu button in the top left corner, and then uncheck the real-time rendering button here to globally stop all animations in the scene. But if you preview the game, all animations will resume as normal. So if you want to stop the tree from moving in the game preview, you can select the tree, go into the Details panel, and then uncheck Evaluate World Position Offset. And now that we've made that change, if we simulate the game and look at the tree, we won't see any motion. Now we'll download another asset. I'll go back into the Fab panel and search for a tank. Oops. And make sure that we're searching for free tanks. And let's get this one called M1A1 Abrams tank. So we'll add this to the project. Now this could cause problems. 4.27 is quite a bit different from 5.5, but we'll give it a go. The Fab description for this tank says that it's rigged, and it comes with animated parts, including weapon firing. And you could open one of these levels to see if you can get a demo of it to play. But again, there could be some compatibility issues because it is intended for Unreal Engine 4. But if you're just wanting to include one of these tanks as a static, motionless asset, you could just drag this skeletal mesh into your level. Now we'll look quickly at Quixel Bridge. So we'll go to the Bridge tab and look through the menu. I really like how the Quixel assets are organized. They're all grouped together very logically, so it's easy to find what you're looking for. And if you find an asset that you want to use in your project, you'll want to select it, and then in the lower right corner, define the quality you want. So in this case, I'll set it to high quality. And then don't click on this download button, but instead just drag the asset in from the browser window directly into your editor window. And if we zoom in on the asset, it's clearly not high quality. The mesh is very low res. It used to be that you could get higher resolution assets from Quixel, but now it seems like only the low resolution versions are available. And again, I think this is because Quixel is being phased out. But even though Quixel assets are lower quality, they may still be good enough for some purposes, especially if they'll only be seen from far away. Over the next few segments, we'll work on making the landscape more realistic. We'll add trees, rocks, bushes, and flowers with the Foliage painter. But before we do that, let's add a material to the landscape height map. We could get rid of the seams on this image and then add it to a simple grass material to cover the whole landscape. But that wouldn't look convincing because in the real world there's variation on the ground where grass transitions to some bare dirt areas, patches of gravel, etc. So fortunately, we can make a special landscape material in Unreal that will enable us to selectively paint multiple materials onto the landscape. So let's go into the My Stuff folder and right click and create a material, and we'll call it my_landscape material, and we'll open that up. And we know for sure that we don't want the landscape to be shiny, so let's hold the 1 key on the keyboard and left click in a blank space, and then just drag this to roughness, and we'll set this to 1 to make it fully rough. Now we need to add some landscape layer blend nodes, so we'll drag out from base color and type in landscape, and so we want to select this one, landscape layer blend. Now we'll go over to the left panel to access the details for this node, and we need to add a new array element. So we'll click on this plus button, and we'll do that 2 more times because we want grass, dirt, and gravel. And let's expand this out. So we'll click on that little drop down tab there. And we want to name the first one grass. So I'm entering that for the layer name. And for the second one, we'll call it dirt. And for the third one, we'll call it gravel. All right, so it should look like this now in the node. And now we can hold the T key on the keyboard and left click, and then plug the top pin from the right-hand side, RGB, into layer grass. And we'll select that node, Control C, Control V to make it copy. And we'll plug that into dirt, Control C, Control V again. And we'll plug this into gravel. Now we just need to assign the textures to these nodes. So with the first one selected, we'll come over to the left-hand side, and where it says none here under texture, we'll just search for grass, and we'll use T ground grass D, which comes with Unreal Engine in the starter content. And for the next one, we'll select it and search for dirt. Actually rust is what we want to search for. We'll use that as our dirt. And for the last one, we'll select it and search for gravel. We want T ground gravel D. We want the landscape to look convincingly three-dimensional with some surface texture. So to do that, we need to add normals. So let's select all of this, Control C, Control V, and we'll just scoot this down here, and we'll plug this into normal. And then we need to change these out. So we'll select the top one here, and instead of T ground grass D, we want T ground grass N. And then we'll do the same thing for rust and the same thing for gravel. We want to be able to adjust the tiling for each of the textures independently. So we need to make a couple more small changes here. Let's hold the M key on the keyboard and left click to create a multiply node. And then out of the top pin, we'll drag out and type in texture. We want texture coordinate. There we go. Texture coordinate. Drag that over some, and let's drag from the bottom one. Well, actually, let's do it differently. Let's hold the one key on the keyboard and left click and plug this into the bottom. We'll right click to convert this from a constant to a parameter. And we want to call this grass underscore tiling. And let's change the default value to 1. Now we can plug this into the UV pin on the left-hand side for grass, and we'll do the same thing for the grass normal. And then let's duplicate all of these nodes, Control C, Control V, and we'll plug this into dirt, but we need to rename the parameter here, and we'll call this dirt tiling. And then we'll copy paste this again down here. Plug this into gravel. And let's rename this from dirt tiling to gravel tiling. Okay. And then we need to plug, oops, I made a mistake here. Let's drag this down to plug it into the normals there and here. And it's looking kind of confusing. Let me scoot back just a little bit. I just want to make sure that we can tell what's going on. Okay, so if we trace out from the top one, grass tiling, it goes there and there, which is right. This goes here and here. Yep, that's all right. Now that we're finished, let's make sure to save the material, and then we'll go back out to the first person map. Now in the My Stuff folder, let's right click on My Landscape material and create a material instance. And then we'll select the landscape. We want to make sure that we're getting the whole landscape by clicking on the top element here. And then in the details panel, with that selected, we'll come down to where landscape material is listed. Because the material instance we just created is still selected here in the content browser, we can click on this button here to use selected asset from content browser. You could also just drag this over though. Okay, so everything turns black, but that's okay. We're going to fix it. We need to go up top to landscape mode. and click on the paint button here at the top. And we should see our layers listed here if we've done this correctly, but we still need to add layer info. The way that that works is for dirt, I'm going to click on this plus button here and select weight blended layer normal. And what this will do is save the information for how we're selectively painting the landscape to a location of our choosing. So I'm going to select the My Stuff folder here and save that. And now we'll just repeat that process for the other two layers. As we're getting ready to now paint the landscape, I think it's very helpful to gather visual reference. After searching Google Images for a while, I found pretty decent results with the search terms mountain, valley, Iceland. Those images look pretty similar to what I'd like to achieve in my own landscape. So I downloaded a few of those images to use as reference. Back in Unreal in the editor window, again, we're in landscape mode and we're set to paint. And I want to go ahead and raise my point of view so that we can see the landscape as a whole. And I'll set the camera speed up a bit to maybe 8. Let's see how that goes. When we set up our layer info, dirt ended up being applied last, so it is the default for the entire landscape. And based on the reference images, it looks like one of the main things that we need to do across the landscape is on the highest points of the mountain where it gets really steep, we want for gravel to show through that kind of lighter color where there is no dirt. And then in the lower, flatter areas, we want to apply grass. But it looks like we want it to be kind of patchy. Let's start by adding grass. So we can click grass here to select it. And then we can change the brush size if we want by just dragging this slider side to side. Now, right now we have the simple circular brush set up. Let's go ahead and just drag across the landscape with grass selected to see what that does. So that gives us a simple uniform paint stroke of the grass material. I think this result isn't very realistic. We tend in the real world to not see huge patches of uniform, exactly similar grass across a landscape. So let's undo that, Control Z. And instead of using this simple circular brush, let's switch to the alpha brush, which enables us to use an alpha, which will make it so that the black areas will have the material applied and the white areas will not. The default one that they have selected here, I don't think is really great because it just will give a very stripy kind of result. And so let me undo that. I think that we're better off searching for a type of noise here. And I'll just use tiling noise 05. Okay, and so now if we drag across the landscape, we do still have that sharp outer edge, but at least now we have more variation in the kind of density of the grass as it's being applied. So I'll spend the next few minutes working on adding the grass, and I'll probably alternate between adding the grass and then putting some dirt back in occasionally to give it some variation. And I'll focus mainly on the flat areas where we would expect for the water to accumulate. Before we go any further, I want to adjust the tiling for the materials so that they are at a realistic scale in the world. And so I zoomed in on an area with a figure close to the ground, and I painted an area of pure grass, pure dirt, and pure gravel here. And I opened up the landscape material instance. We want to enable the modification of all of these parameters. And I think let's start with grass. It looks like when we go higher, that looks less real. So I'll try going down to maybe something like that. Looks pretty good. 0.25 for the gravel. Yeah, maybe something like 0.6. And for the dirt, we'll set this to about 0.2. I think that looks good. Now, it might be different on your landscape, but I think This gives us a decent starting point. Then once we're happy with the result, we'll save it and close the instance. Now I'll work on adding gravel texture and detailing. In these next steps, I'll look closely at my visual references and try to pull in details I notice in them to make the landscape look more natural. I'll go from general to specific, making the biggest changes first with a large brush, and then working with a smaller brush later on to add nuance. And I'm trying to not get too hung up on making this perfect because the trees, rocks, bushes, etc. are going to wind up covering up a lot of these areas. And anyway, I may need to come back and make additional changes after those assets are put in place. You'll see that I periodically preview the game because I want to make sure that everything looks good from the first person point of view. We've already gone over all of the main things you need to know about to use these tools, so I'll do these final steps as a time lapse to finish out this segment. In this segment, we'll add sculptures to eliminate the placeholder geometry. For some quick context, these sculptures all have algorithmic origins. Some of them are 3D fractals made completely from a formula, and others I made manually in Rhino, drawing inspiration from some form studies I did with generative AI. When first importing the sculptures, they were way too small. Yes, you can scale them up after the import, but I get worried when they come in this small because Unreal will ignore very tiny mesh faces. This means that you can wind up with holes in your model. So I re-imported with offset uniform scale set to 100 or even 1000 in some cases, which makes the imports much bigger. Then I moved the sculptures into position. We haven't yet covered this, but if you need to drag an asset a long way, you can hold Shift and left mouse button drag. This will make the camera follow the asset, which makes things much easier. One of the sculptures had several different parts that I had to group together with Ctrl G. And then later, if I need to ungroup, I'll do that with Shift G. I decided to add a sculpture in the lake, like I've seen in some sculpture parks I've visited before. Once the sculptures were positioned, I added materials. I kept the materials pretty simple in the interest of time and leaned heavily on the starter content. The final sculpture has colorized vertices, so I was able to use the Vertex color material we created in an earlier video. And I decided to add a couple of benches too in order to help the space look more like a park. Now that all the sculptures are in place, in the next segment we'll turn our attention to the trees. Let's add some trees to the landscape. The first step is to find some good tree assets to download. On Fab, I look closely at preview images to assess the quality. I want to make sure that they look realistic first of all. Next, I look for assets that are low poly or at least reasonably streamlined, because we're going to add hundreds of trees to the landscape, so they will have a big impact on performance. Using high poly trees could really hurt our frame rate. The first trees I found on Fab were in a pair. They looked good on Fab, but when I added them to my project, I found that both trees were in the same static mesh. If we used a pair of trees in the Foliage Painter, the placement wouldn't look random at all, so I had to ditch this model. I found this asset pack called Temperate Vegetation Spruce Forest, and the trees look phenomenal, so I decided to add it to the project and give them a try. In the Content Browser folders, I found big, medium, and small trees, and they are organized in subfolders for high and low, which refers to the poly count. So I dragged some of the low poly trees into the project and they looked really good. And I decided then to move on to use them with the Foliage Painter. At this point, I realized I didn't have any good visual references for placing the trees. The images we used in the landscape segment were great for thinking about the grass, dirt, gravel texture placement, but apparently there aren't many trees in Iceland. So I did another image search, this time of Storm King Sculpture Park, which I had a chance to visit about 10 years ago. It's in upstate New York and it's totally worth a visit if you get a chance. Anyway, what I notice about the photos from Storm King is that the density of tree cover varies considerably from one area to another. And there are some places where the sculptures seem to have been positioned almost in juxtaposition with a neighboring tree or bank of trees. So I'm going to try to do the same thing as I place the trees in my level. To use the Foliage Painter, we'll need to switch over to Foliage mode. Make sure that you're then set to paint, and now drag the meshes you want to use over into the foliage panel. You'll have to decide where you want to save the foliage info. I put it in the My Stuff folder so that I can find it later. I dragged several different sized trees into the foliage panel because I want some variety. Then it's just a matter of adjusting the brush size and paint density to get a reasonable result. I had to set the density way down to 0.001 to get a moderate density of trees. But if you use a smaller brush, you'll get a different result, so you'll have to fiddle around with this setting. So if you left mouse button drag, it will add the trees, and if you shift left mouse button drag, it will delete them instead of add. The trees will be placed relative to the surface of the landscape, which can sometimes get the trees to lean to the side. So while still in foliage mode, I switched to select, and I went around and stood some of the trees up. Now remember that when something is selected, you can Alt left mouse button drag to orbit around the selected item. That helps a lot. And if there's an area that is too dense with trees, you can thin it out by switching to Erase, and you'll need to then set a very low value. In my project with 0, the brush removes all the trees, but with 0.0005, it thins them out. When you're finished with foliage painting, just make sure to switch back to selection mode. In this segment, we'll add rocks, weeds, and flowers with the Foliage Painter. This will give us a chance to explore some of the other settings we didn't use when adding the trees. The flowers and weeds were pretty easy to find on Fab. I used Temperate Vegetation Ground Foliage for the weeds, and Interactive Open World Foliage to get the flowers. The rocks were a bit more challenging to find. Searching for rocks, plural, didn't lead to any good asset packs that I could find. So I searched instead for rock, singular, and downloaded them one at a time. By the way, for some of the rocks, you'll need to select the free license and then choose the quality that you want. I set the quality to low because I want low poly geometry that will perform well. To use the rocks in the Foliage Painter, I first had to uncheck the trees, and then I dragged the rocks into the Foliage Painter. Then, when I painted the rocks, I found that some were way too small, so I had to select the rocks individually in the Foliage Painter, then go into their settings and adjust their scale one at a time. This is a little bit tricky though, because the scale adjustment won't apply to the stuff you've already added to the level. So you'll have to adjust the scale, paint with left mouse button drag, then look at the result, then shift left mouse button to delete, then adjust the settings and try again. By the way, in the filters section toward the middle of the Foliage Painter, you can uncheck static meshes in order to not paint on the water. And after I added all of the rocks, I wanted to make a second pass and add some smaller ones. So I selected all of the rocks in the Foliage Painter and adjusted their scale all at once, which was a lot faster than doing this for all 5 individually. So now that I've covered all of the main points for this segment, I'll do the rest as a time lapse. In your project, there could be a few minor issues to fix with navigation, meaning how the player can move around in the level. In this segment, we'll briefly go over the problems I think are most likely to come up. Because we're working in the first-person template and we've added a landscape, things should work pretty much as expected. If we click on the Show button in the top left and turn collisions on, we can see that the sculptures have collision meshes, as indicated by this faint wireframe. However, the trees don't have any collisions set up. This means that if we play the level, we will not be able to walk through the sculptures, but we will be able to walk through the trees. If we want to turn the collision off for a static mesh, we can just select it, then go into the Details panel, scroll down to Collision, and set collision presets to No Collision. In my project, we are currently able to walk out onto the water, which isn't very realistic. I tried setting the water plane's collision to Block All and set it so that the player can't step up on it, but that didn't help. Probably the easiest solution is to open the Place Actors panel, go to Shapes, drag in a cylinder, and in its Detail panel go to Rendering, and then click Actor Hidden in Game. Then just copy and paste these around to cover the water. Finally, you can toggle the visibility of the cylinders in the World Outliner so that they won't be so distracting as you continue to edit your level. Now if we play the game and try to walk out onto the water, we will be blocked by these cylinders. If you've made a sculpture that you want the player to be able to walk on, you'll need to open the sculpture's mesh in the Static Mesh Editor. You can do that by selecting the sculpture in the level and then double-click on the mesh in the Details panel. Or you could just double-click on the mesh in the Content Browser. Then in the top left of the screen, go to Show, Simple Collision. This is the collision being currently used in the level. Now click on Show Complex Collision. This is what we want to use in the level. In the right column, go to the Collision section, find Collision Complexity, and set it to Use Complex Collision as Simple. Now save the changes in the top left and go back out to your level, and you should see that the change has been applied. I've made a quick example here with a scaled up version of the sculpture that we can walk on. Sound plays an important role in making a project believable. To add sound to our level, the first step is to find a WAV audio file. Here I'm downloading from Epidemic Sound, but there are plenty of other free sources of audio out there on the web. We'll import the WAV audio track to the My Stuff folder. Now we'll right-click on the file and create a cue from it. Now we'll want to double-click on the sound cue to open it, then click on the input. And we want this to play in a loop, so we'll go over to the left-hand side and click on this box for looping. Then we can go back out to the level and drag the sound cue into the level in a central location. And I'm just trying to set this up so that we have an even kind of sound of the birds chirping across the entire landscape. So with the sound cue still selected, we'll go into the Details panel and go to the Attenuation section, and we want to click on the box to override attenuation. And from there, the next thing we need to set up is we need to make sure that the outer radius is wide enough to encompass all the area where we want to have sound. So I'll go high above so that I can see how wide this radius is, and then we'll just change this setting in the Details panel to make it bigger. In this final segment, we'll go over a few points on how to preview the level to make a good screen recording and how to prepare the project for packaging. Again, if we want a larger view of the editor window, we can just push F11 to make it full screen. And pushing G will turn game mode on and hide the icons. So if our goal is just to make a screen recording walkthrough of the level, then this will work decently well. But if you're getting ready to package the project, it's helpful to preview it as a standalone game. If we do that, we find two problems. The first is that the project opens in a small window, which is hard to see. It would be much better if it were full screen. The second problem is that when we're finished playing, we expect to be able to quit by pushing escape. But right now, pushing escape does nothing. So let's Control-Alt-Delete to kill the standalone game. And now we'll open the level blueprint. Click up top on this dropdown and go to Open Level Blueprint. Now in the event graph, we'll right-click and type in ESC, and under Keyboard Events, we'll click on Escape. So we want to drag a wire from Pressed and then type in Execute Console Command. And for command here, let's click and make it Quit. Then we'll right-click again and type in Event Begin Play. And we want to drag a wire from this. And again, we'll execute console command. Here we'll type full screen, one word, no space. And then we'll go up to the top left and compile and save this. And then go back out to our level. And now if we preview again, it will load full screen. And if we then push escape, it will close out the game. At this point, we've covered all of the basics needed to make a sculpture park in Unreal Engine. If you have any questions, feel free to post a comment below. I would be happy to help out. And if you found this video useful, a quick positive comment and thumbs up would mean a lot to help my small channel grow. Take care and good luck in your Unreal Engine projects.